Hello everyone. In our previous lectures, we have studied about refraction of light. So what is refraction of light? When light travels from one medium to another medium, it bends. But why does it bend? We have seen that light bends because it travels in different speeds in different mediums. So when the optical density of the medium increases, the speed of the light will decrease. But in what direction will it bend? We have two scenarios here when light is traveling from medium 1 to medium 2. Let me take medium 1 as a rarer medium. Let me take medium 2 as a denser medium. This is my incident ray and this is my normal. The angle that the incident ray makes with the normal is called the angle of incidence. Now, if this surface was not there, or I can say if there was no change in medium, this dotted line would have represented the direction of light. But since there is a change in medium, light is bending. But here, since it is traveling from a rarer medium to a denser medium, the speed of the light is now decreasing. As the speed of the light decreases, the angle that it makes with the normal also decreases. So in order for that to happen, the light has to bend towards the normal, and so it does. So we have angle of incidence, we have angle of refraction. So in this case, angle of refraction is less than the angle of incidence. We have one more scenario where light is traveling from medium 1 to medium 2, but in this case it is traveling from a denser medium to a rarer medium. We know when light travels from a denser medium to a rarer medium, the speed of light will increase, and as the speed of light increases, the angle that it makes with the normal also increases. So we have light coming in this way. This is the incident ray. This is my normal. Angle that it makes with the normal is called the angle of incidence. If this change in medium was not there, this would have shown the direction of light. But since there is a change in medium, light will bend. But in what direction will it bend? Since the speed is increasing, light has to make more angle with the normal. That is, it has to bend away from the normal. So it does. So we have angle of refraction here. So in this case, angle of refraction is more than the angle of incidence. So the funda is simple. When light travels from a rarer medium to a denser medium, it will always bend towards the normal. And when the light travels from a denser medium to a rarer medium, it will always bend away from the normal. We will use this concept to learn about how light will bend when it is passed through a glass slab, a rectangular glass slab. Let's see what happens when we shine light through a rectangular glass slab. So let us consider a rectangular glass slab ABCD. We are looking at it from the top view. So here is my surface AB. Let me shine light on it from this side, that is the bottom side. So here is my incident ray, incident on the surface AB. Let this be the point of incidence, and this what I have drawn with a dotted line is a normal drawn at the point of incidence. My incident ray makes an angle I1 with the normal, and I call this the angle of incidence. If this rectangular glass slab wouldn't have been there, then light would have traveled straight through. But since light is traveling from one medium to another medium through a glass slab, light will change its direction. That is, light is traveling from air to glass, and we know that air is a rarer medium, glass is a denser medium. We have already studied that when light travels from a rarer medium to a denser medium, it will bend towards the normal, and so does our light bend towards the normal. So we have this refraction, and we call this angle of refraction as R1. Now, if this, again I repeat, if this rectangular glass slab was not there, light would have continued its journey. So here, light would have continued its journey this way. But since there is a rectangular glass slab, again the light will bend. That is, light is traveling from a denser medium, that is glass, to a rarer medium, that is air. When light travels from a denser medium to a rarer medium, we have studied that light will bend away from the normal. So here we have this incident ray, that is incident on CD, that is why we call it as an incident ray. I will name it as I2. So this is my normal. Angle made by the ray with the normal is called as the angle of incidence. Now, light would have traveled straight if there was no change in medium. But since there is a change in medium, light is bending, and it is bending away from the normal because light is traveling from a denser medium, that is glass, to a rarer medium, that is air. Now, if you observe carefully, the ray that is emerging, we can call it as an emergent ray. The emerging ray or the emergent ray is parallel to the incident ray, but is shifted by some distance, by some lateral distance, and we call that shift as lateral shift. And this is what happens when light is shining, or when we shine light through a rectangular glass slab. We can verify our theory by doing a very small experiment. To do that experiment, all we need is a rectangular glass slab and a laser. So let us do the experiment. I'll dim my lights. So I hope the path of the laser beam is visible to you. So when I shine light and the light is traveling the same medium, it is traveling in a straight line as it's supposed to. But when we shine light through this rectangular glass slab, it is bending. I'll do it again. So this is the direction of light when it is traveling in air or when it is not traveling through glass. But when I shine light through that rectangular glass slab, or here it is bending, and it is exactly how we have explained in the theory. So physics works. The white spots that you see on my chart paper are due to talcum powder. I've used talcum powder to increase the visibility of my laser beam. Why or how does talcum powder increase the visibility of my laser beam? Well, that's a topic for some other day. I hope you have liked the video. Thanks for watching.